Hi, welcome to the second video dealing with fine-tuning. In this video, we'll see an end-to-end example of a production-grade fine-tuning and deployment. We will use Amazon AWS Bedrock for it. So this is the single guide that you need to fine-tune your own models. Now, if you haven't watched my previous video comparing fine-tuning and RAG, Retrieval-Augmented generation, you must watch because that clarifies the general misunderstanding about fine-tuning. Normally, we don't need fine-tuning at all. Remember, fine-tuning will not add new knowledge to the model. Fine-tuning is only to adapt the model's response style. Welcome to Techie Talks AI. I'm Sri from Shogini. On this channel, we bring you hands-on demonstrations and insights into the latest tools and trends to help you get started with ease. Don't forget to subscribe and be a part of our journey into the future of technology. So if your application is related to engineering, medical, or legal, you want the model to respond in certain ways. Fine-tuning a model can help the model respond in certain specific pattern. So it does not add new knowledge, and if you're looking to add new knowledge, RAG is all that you need. In case your use case is clear that you need to fine-tune, this is the guide that you need. So let's go over these slides before we get into the practical demonstration. Why fine-tune? Adjust the pre-trained model's behavior to match specific needs. So remember, behavior, not knowledge. Teach the model brand tone, polite or English. English is a demo that we will use where Indian English, Indian language, Hindi is an Indian language, and normally we mix Hindi and English and we call it English. Fine-tuning can also help the model to give always JSON output or structured text, and of course improve performance on a domain specific data, legal, medical, technical. But remember, most of this can also be accomplished using proper prompting. So proper prompting and RAG is good enough. Always remember that. Okay, so now in order to fine tune, you need data. And remember, these data is in the form of examples. So how to prepare data should be in JSONL format. JSONL is JSON, but each line is a complete JSON starting with a curly bracket and ending in curly bracket. No comma at the end of these lines. So standalone lines, curly bracket starts here, and prompt, how are you, and completion. And this prompt and completion naming can vary depending on the model. So AWS Bedrock, the model that we are using, will expect it to be prompt and completion. Any data that you have which you want to fine tune, you can ask ChatGPT to create a Python script to format the data in this way. So remember, collect aligned input-output pairs. So the prompt and the completion output should be matching. And clean text, no spaces. And also remove noise, remove irrelevant prompts and completion, and also avoid duplication. And ensure that the style is consistent so there is no confusion. Save in UTF-8 JSONL, one line per example format. So how to fine-tune using Bedrock? A quick walkthrough. You need to upload the JSONL dataset to an S3 bucket. I will show you that. And in AWS console, Bedrock, fine-tune models and select source model. So we will use this Cohere Command Light text model and set the hyperparameters and launch the fine-tune job. Now this job can take an hour or so, depending on your data and number of epochs that you are running. Now, the biggest problem is there are hundreds of videos on how to fine-tune models, but none of them talk about how to deploy them in a production-grade environment. So that is what we will see in this video. So once fine-tune complete, Bedrock creates a custom model ARN. So you have to provision the model to get this ARN. We will see that. So you can do this via API and also via the console. And how to test the model? Bedrock UI itself we can test, but we will also use Python to test. Okay, now how to access the model in Python? So this is the sample code that we will use to test the model. Boto 3 is the AWS Python SDK, which lets us talk to AWS resources. So that is a quick overview of what we are going to see. Now let's look at the data that we are going to fine tune. Okay, so here is the data that we will use to fine-tune our model. The prompt is in English and the response is in Hindi or English, mixture of Hindi and English. What is the name of the movie? The completion is film का नाम क्या है? Do you think you will like the movie? क्या आपको लगता है कि आपको film पसंद आएगी? So like this, I have 1,000 sentences. Now, how did I get these sentences? You can get it from Hugging Face. So here I am using Kaggle. Here you can log in and then click here to download. And the downloaded data format is not the way we want. So downloaded data format looks like this. This translation English, what is the name of the movie? In English, film ka naam kya hai? So there are unwanted items in it. Though this is in JSONL, we only need prompt and completion keys. I've got this Python script using which you can easily convert. Okay, so input file is the JSONL I just showed you. This file has over 10,000 lines. Just to keep it short, I am picking 1,000 lines and formatting it in this format, prompt and completion. That is it. Just run this Python script on the same folder where you have the downloaded Kaggle file. You will get this ready to be used, properly formatted file. Now what we need to do is, we need to upload this file. So I have created a bucket, S3 bucket in AWS, fine-tuning demo Shogini. And I have uploaded that JSONL that I have showed you. These are my other fine-tuning files. This is the input that will be used to fine-tune our model. I have an output folder which I have defined here. That will contain the fine-tuned model parameters. 2 steps we have completed. That is, preparing the data for fine-tuning. Remember, we are not adding new knowledge. We are only adapting the model's response style. We have given 1,000 examples of how model should respond. Then we uploaded that formatted JSONL to an S3 bucket. Then we come to AWS Bedrock. So this is the Bedrock landing page. Here, click on Custom Models. And here I have 2 fine-tuned models. I will just go over the screen involved in creating this fine-tuned model because that is going to take an hour or so. So I will show you what we need to enter. Here, click on Create Fine-Tune Job. Remember, this can be done using API as well. But at least once or twice you must do this using console so that you know what it takes. So I'm giving it a short name, Fine-Tune 9. I will select the model here. I will choose Cohere Command Light. And remember, the S3 bucket and this Bedrock both should be in the same region. Otherwise, the bucket won't be listed here. Okay, so job name also I will give it FT9. And here, input data. So this is the uploaded English file containing 1,000 JSONL lines. If you have a separate validation data set, you can specify it here. Otherwise, it will take a percentage that we specify here. Evaluation percentage, say 20% of the data it will take from our 1,000 lines for validation. I am not uploading separate validation data here. Then hyperparameter epochs, I tried with 1, 2. You can try with different numbers to see what is giving consistent expected results. The batch size is how many lines of our input data it will take during one iteration. Okay, so you can choose these numbers. Okay, and learning rate, you can leave it untouched. After one successful fine-tuning, you can try these parameters to see how fast it completes and how accurate it is producing, etc. So early stopping threshold, this is the minimum amount of validation loss you can set. I'm not changing any of these. This also will leave it at 20. That is 200 lines out of 1,000 lines it will use for validation. Then here is the output where the trained model should save its output and choose the folder within the bucket for the output. Okay, and then here you need access to the S3 bucket. I already have the role. If you don't have the role, you can click here to create. It will create on its own. We don't need to worry about it. Click on Create a Fine-Tuning Job. I'm not submitting this now, but I've already done it multiple times. I will show you the errors that you can get. See here, if your data is small, you can get validation error as well. So in this case, I only had 50 lines of data. Okay, so I got validation error. Then in this case, see here, input data validation itself failed. It is saying input data should have prompt and completion. At that time, I only had input and output. Then FT7, I had one epoch. FT8, I had two epoch, just to compare. Those are the models that are currently provisioned and live. Okay, so I have two models now fine-tuned. Now, if you click on this model name, toward the end, you will see the provisioned throughput. That is where the model has been deployed. I have deployed with 1 unit. Okay, so depending on your load, you can provision more number of units. So this is an excellent case where you can have a scalable deployment of your model. If you click on the deployed model, you will get the model ARN. See here, model ARN. That is what we need to copy and use it. Before we do that, we will see how quickly we can test it. Click on this chat text UI. Click on select model. Come down to see the custom models where I have my custom models. Okay, and click apply. So we have this UI. What we will do is we will ask some questions. So the movie tries to stop the war, not be in it. Let's ask this. So the temperature is 0.7. इस मूवी के बारे में क्या war रोक देता है? The model has learned to respond in English. See this? So this is not English. This is Hindi in English text. Okay, so that is a quick demo of how we can use the UI to test it. Now what we will see how we can use API to test it. So I have the code here. No, not gaslight. Let's see if that is there in the text. No gaslight. So let's run this from command line. So this is the Python script. Run.sh is my Python environment. Okay, so no, not gaslight. Nahi gaslight nahi hai. So here the answer is na gaslight nahi. So it's able to respond the way we have trained. I have added the ARN. So this is the ARN that I have specified, which I got it from the AWS Bedrock. If you see the custom models, FT8 and provisioned, here you get this ARN. See here, ending in this hash D8PK. So that is a simple Python code using which also you can access the model deployed in a production grade environment. Give your valuable comments and suggestions. Please let me know what else you would like to know in case of production grade deployments and fine tuning. Please remember to like, share and subscribe. See you in the next video. Bye bye.